Good morning, everyone. We have reached my favorite topic. Drumroll, please. Schrodinger's cat. You may be thinking, well, why on earth do I care about some physicist's cat? Well, you care because the cat is both dead and alive at the same time. Schrodinger's cat was a thought experience developed by Erwin Schrodinger in order to protest his own hypotheses. He really didn't like the implication that everything in nature is fundamentally probabilistic, so he set out to design an experiment to discredit the Copenhagen interpretation. It's a little bit weird, but also sort of awesome. Most important thing is do not try this at home, and no cats were harmed in this experiment, because as its name suggests, it is a thought experiment and it's purely theoretical. So here it is. A cat is locked in a steel box with radioactive material, which has an equal chance of decaying or not decaying. If the atoms decay, it will trigger the destruction of a vial of poisonous gas, which means dead cat. But until the box is opened, which causes the collapse of the system's wave function, the atom is in a superposition of two states, decay and non-decay, i.e., the cat is both alive and dead at the same time. Logically, this experiment makes no sense. A cat that is both dead and alive? What? And that was Schrodinger's point. In the real world, it makes absolutely no sense. But when you think about it in terms of the quantum world, it actually follows all of the principles we know. Because of particle-wave duality, the cat's wave function can be in a superposition of the two possibilities until we observe the cat, which causes the collapse of the wave function by cementing in one of the many, many possibilities that lie on that wave function. Schrodinger's cat is also a very good opportunity to further explain quantum entanglement. Imagine two boxes with the same experiment, each with a cat that could be both dead or alive. Let's put these cats in a state of entanglement. Right here, right now, if we opened up those boxes, there are four options. Either both will be alive, both will be dead, or we'll have one of each. But because of quantum mechanics and entanglement, we know that it actually isn't possible for both to be alive or both to be dead. We wouldn't know exactly which one was which before observing, but you can always count on the fact that one will be dead and the other alive because they are in a state of entanglement. Now, let's leave one here in your physics classroom, bedroom, kitchen, wherever you're watching this video. And let's send the other one to the other end of the universe, to Middle Earth, to Endor, wherever you want, just as long as it's super far away. Let's say we send it to Endor, and we open it at the same time as we have an Ewok open it there. Even though we are thousands of light years away, maybe even in a different time, one cat will be alive and the other will be dead. Because they are in a state of entanglement, no matter where in the universe they are, one will always be dead and the other alive, even though which one is which is completely undetermined until the outcome is measured. This brings up the very important idea of an observer in quantum physics. If measurement is causing the collapse of the wave function, does observation then create the universe? Who can be an observer? Any ordinary person, or does it have to be a physicist? Does the person who is making the observation have to be observed in order to exist, and then that observer have to be observed, and so on and so forth? We don't know. All we can do is continue to investigate our quantum world and find even more possibilities every time. Thanks for watching.